Hello, welcome. My name is Alex Goldberger. I will be defending my capstone project, Motivating User Interaction Through Social Network Visualization. The committee chairs for the project are Dr. Deb Geers and Dr. John Shaw. So before we get to my work, let me share with you an initiative that was going on at RIT while I was looking for capstone ideas. The initiative was to increase research across the Institute. In 2013, Dr. Deb Geers won a grant for her research idea, a role motivation interaction framework for collaborative research. She found that in order to increase collaboration and idea sharing, which would be a change in behavior, the motivations of researchers at RIT needed to be understood. Dr. Stephen Reese's theory of 16 basic desires was used to discover that researchers at RIT are highly motivated across the board by curiosity. They are also motivated by honor and idealism. Interviews with researchers led to discoveries that RIT did not possess good pathways for interdisciplinary research, especially for newer faculty. To increase collaboration, the project known as George was created by Dr. Geers. George uses what are known as scholar trading cards to help RIT faculty condense and share their work and expertise. Each scholar trading card contains the skills, research areas, affiliations, publication keywords, and fun facts of a scholar. Here you can see the card of Dr. Geers. Cards exist in print and digital forms, which allows scholars to share them in many different ways. Anyone with an RIT login can go to george.rit.edu to view the card database and collect their own digital cards. On November 20th, 2014, a celebration of research was held to share the work done by the George Project team. At this point, new cards were being worked on and new connections were being made, but there was no way to record and show these connections. After November 20th, George shifted from focusing entirely on researchers and moved to encompass more of the RIT faculty, which were then referred to as scholars. The problem was that scholars lacked a means to determine how they were connected with others, that is, tie strength between themselves and other academics, potentially useful for collaboration and new knowledge creation. The answer would need to be something that not only gave scholars a means to determine how they were connected with others, it would also have to be something that scholars would be motivated to use. The next step was to determine how to best display connections between scholars. My research covered information visualization theory, motivation psychology theory, gamification, applications of information visualization in social networks as described in the literature, and finally, examples of social network visualizations. An example of motivation psychology theory is Dr. Stephen Reese's theory of 16 basic desires, which holds that everyone is motivated by 16 motivators and each individual prioritizes these desires differently. As I mentioned before, researchers at RIT were found to be highly motivated by curiosity, honor, and idealism. A goal for this project was to design toward these motivators. Another example of motivation psychology theory is self-determination theory, which breaks down motivation into intrinsic motivation and extrinsic motivation. Intrinsic motivation refers to something that is done because it is inherently interesting or enjoyable, while extrinsic motivation refers to doing something that leads to a separable outcome. Extrinsic motivation is considered an impoverished form of motivation. Cognitive evaluation theory is a piece of self-determination theory which establishes that intrinsic motivation is affected by feelings of competence and a sense of autonomy. With that in mind, it became important to create a solution that was optional to use. Creating something that was essential to the faculty evaluation process would not be intrinsically motivating to use. Its use would be fueled by a separable outcome. A lot of research and decision making went into answering the question, what is the best way to represent a connection between two people? The concept of tie strength came to the forefront. In 1973, Granovetter defined tie strength as the strength of a tie is a probably linear combination of the amount of time, the emotional intensity, the intimacy, mutual confiding, and the reciprocal services which characterize the tie. This definition helped shape how the George team collected data about connections between scholars. In 2010, Hengal, McLean, Lamb, and Heer wrote that a social network that capitalizes on weak ties and asymmetrical connections will be able to trace more accurate and useful paths. The idea of using asymmetrical connections was an important design consideration at multiple points in the project. At the bottom of this slide, you can see a screenshot of forcoa.net, an online tool which provides a visualization for computer science authors whose publications are registered in the Digital Bibliography and Library project. Forcoa.net differentiates between connections of different tie strengths by increasing the line thickness of edges, which can be referred to as edge weight. 4COA.net also allows users to see how a connection changed over time. In this case, the edges represent co-authorship. Clicking on one of the edges will bring up a graph showing the relationship between the authors over time. Let's go over some other visualization examples, this time from outside the literature. On the left, we can see the Friends visual map, which shows my Facebook connections grouped based on their connections to each other. For example, the continent in the top right houses most of my friends I met during my undergraduate studies at RIT, while the continent below that one, on the far right, is home to my RIT friends from graduate school. 3 of the continents house friends who went to my high school, somewhat separated by graduation year, and we can see a small continent at the top representing friends with 0 connections to any of my other friends. To the right of that, we can see the friend wheel, which puts all of my friends around a circle and draws lines between connected friends. Below that is touch graph, which displays each of my friends in a graph of nodes connected by edges, which represent their Facebook friend connections between each other. Touch graph ranks friends as social connectors. A social connector is someone who connects together groups of your friends that are otherwise disconnected. The top 3 people include a friend who I went to high school, college, and summer camps with, as well as my older brother. In the top right, we have Sociolab, a tool used to show LinkedIn connections by graphing users and their connections as nodes and edges. The official LinkedIn network visualization tool was called InMaps and was active from January 2011 to September 2014, but was shut down for resource reasons. Unfortunately, many visualizations like these can no longer be created and viewed. In April of 2015, Facebook modified its privacy policy and its API, which has made it harder for apps like these to create visualizations that depend on connections between your friends. After completing the research, it was decided that this capstone would focus on creating a social network visualization that interfaces with the George database, provides value to scholars by allowing users to view their connections to other scholars, and motivates users to use and participate in the visualization by designing towards curiosity, honor, and idealism. Before we take a look at some of my early designs, let's go over how the visualization would interface with the George database. At the start of the project, connections between scholars could not be measured. Working as part of the George team, I helped create a set of questions that would allow users to report on the nature of their connections to others in the network. We modeled our questions after the format LinkedIn once used, when users attempted to make a connection invitation so that our users would not feel that we were asking too much of them. We tried to tap into their expectations of social networking sites. Like LinkedIn, we asked, "How do you know this person?" But the responses we allowed for really targeted the question, "How much have you interacted with this person?" Going off of Granovetter's work, we felt that time spent together would be a useful measure of the connection. This was the bare minimum needed to move forward with asymmetrical ties of varying weights and could be quickly implemented into the George website. In the future, the George team had plans to modify the weight of these self-reported connections by tapping into the data on the cards, such as college, department, affiliations, and more. If 2 users are in the same department, their tie is likely stronger. At this point, the database was not set up to facilitate that kind of information retrieval. With these questions and responses in hand, I had a concern for privacy. If we could show the answers to these questions on the website, users could more accurately understand the connections, but we would likely need permission from users to share this potentially private information. Now, let's take a look at some of my early designs. For my early designs, I made the assumption that the network would have Deb Gears connected to everyone, since she worked closely with each person who joined the George network to help make their card. I also connected Dr. Nick DeFonso to each of the members who he had referred to the project. DeFonso, Marshark, and Volo had 2-way connections to Dr. Gears to represent the work they had done with her to ensure the success of George. In this design, we can see each scholar represented by a node, colored to show their college, and each edge shown as 1- or 2-way connection. The arrows indicate a 1-way connection, while the thicker lines without arrows indicate a 2-way connection. This next design on the right-hand side was based off an idea of Dr. Gears called the collaborameter, as seen on the left. The idea was to group scholars by similarity. On the right, I manually grouped scholars based on the information on their cards. For example, Dr. Clofus and Dr. Williams are placed in close proximity to one another because they both have the publication keywords criminal justice, and they're both in the Department of Criminal Justice. This design would be good for guessing at the likely connections in the network rather than displaying the self-reported connections. These next designs were inspired by a visualization of co-occurrence of characters in scenes in the book Les Miserables, as seen on the left. On the right, we use the connections I'd imagined earlier to show connections between scholars. In this case, we assume everyone is connected to themselves. Here, we see the same design, but we no longer assume users are connected to themselves. This provides a more useful visualization. You may have noticed in the top left that the boxes containing the word people each have a down arrow. These drop boxes would allow users to view scholar attributes beyond just connections. For example, if users selected skills, this could act as another way to search on the George website. At the time, the George website had the functionality to let users search for a specific skill, which would bring up each card that contains the skill on it. Here, we can see a user is searching for the skills grant writing and PhD or mentoring, showing each scholar with at least one of the skills. As they search for a third skill, the system would use completion matching to provide possible skills the user may be searching for, based on what they have typed so far. In this case, let's try project management. By adding project management, we can see that Marshark is listed as having the skill, and Gears is added with just that skill. If we click on a scholar's name, the row is highlighted, along with each relevant skill, to make it easier to focus on a specific user in the table. We can also see a thumbnail of the scholar's card. By clicking on this card, we can view the scholar's card in detail. If we had instead clicked on a skill, the relevant scholars would have been highlighted. The idea behind this searching design was to help scholars find particular people for their projects. In this case, maybe we were looking for someone who could manage a new PhD mentoring program created to help teach grant writing techniques. Now we would know who would be good to reach out to. Let's take a look at another design. With this design, each college is shown as a cylinder, which represents the number of users and connections a college contains. Using the connections I described earlier, we can see that most of the colleges are small because they only have one scholar with a single connection. GCCIS and COLA have large cylinders because they have more members and connections than George. Here, I've switched out the Google Maps background for a map detailing the building names. With this design, colleges can be selected. Selecting the college shows all of the scholar cards and their connections. The connections are colored based on the college. We can also click on specific users to see their connections. Here we can see that Dr. DeFonso is connected to most of the other COLA users. Dr. Clofus is not connected, but is part of the COLA college, so his card is grayed out. Dr. Gears is connected to Dr. DeFonso, so she is added to the visualization. One of the pieces of feedback I received from the George team on this design was that the details behind the cylinders were not clear. Volume isn't obviously related to connections and user counts. Next, we'll look at a demo of this idea that attempts to reconcile this issue. In order to help users understand how the cylinder shapes and sizes were formed, I imagined that the cylinders would animate once the map had loaded, and that they would show the relevant statistics as they were being calculated. I made this prototype with HTML5 canvas. Here, we see some incomplete ideas I was working on. I was trying to tap into idealism and honor. In this case, we can see a tree representing each college. The tree roots are made up of the scholars and their connections. Each tree, like the cylinders, would grow as new scholars were added and new connections were made. Honor may be found here as scholars can take pride in the growth of their college. George aims to help create cross-campus collaboration and breaking out of silos, so external connections have a bigger impact on the tree's growth than internal connections. Idealism could be met here because scholars can see how the institution is breaking out of silos, and they can aim to do so themselves as well, thereby improving their world towards a more ideal state. After reviewing the designs, goals, and potential scope, it became clear that the node and edge visualization would be the best fit for this project. I included some of the other designs, as people with different goals or scope may wish to pursue them. Besides the node and edge design, I feel there were many shortcomings to the other designs. Showing entire cards would likely get messy when many scholars are in the visualization, and the cylinders may be a little too complicated to understand. The search table visualization likely wouldn't motivate users to participate any more than the basic search functionality in George would. A simple design allows for more iterative design in the future. I hope that if someone takes on this project after me, they would start by gaining feedback on my work and using that to drive the next design. Here are some of the tools and technologies I used throughout the project. The Adobe Suite was used to make the mockups. Notepad++ was used for text editing. MOBA Xterm was used for SSH. Molly is the framework behind the George website. I made my visualization as a .maml file so it could be housed on the George website. The George database was used with PHPMyAdmin to collect the connection data. A fellow student, Ravi Gunda, wrote the queries that collected the data. D3.js is a JavaScript library I use for the viz.js is another JavaScript library which I use for the final design. Let's take a look at some of the first prototypes. Here are some images of the stages I went through with what I call Visualization A. I used fake data in the D3 library to create the first visualization. As you can see, I'm in the first image in the top right along with who is this. Next, I add actual data from the server to create the visualization in the bottom left. A few attribute tweaks led me to the visualization in the bottom right. The basis for these last two visualizations came from an example I had found on the web. My attempts to manipulate the visualization were really slowing down due to lack of understanding of the code base I had started with. I did some research into other options, which led me from the d3.js library to the viz.js library. Visualization B used the viz.js library. I basically started from scratch and got this code up and running in no time. Once I had matched the capabilities of Visualization A, as you can see on the right, I began progressing on my design. Visualization B2 took more data from the query Ravi had provided for me. I used the college of each scholar to color the nodes, and I used the connection values between scholars to modify the thickness of each edge. Scholars with cards in George each have an avatar photo, which Dr. Ron Volo creates from the cards. Visualization C pulled the avatar photos into the visualization for the nodes. In order to continue representing the colleges, I moved the colors to the border of each node. Visualization D was almost the final stopping point for me. I had made slight adjustments to make each scholar's college easier to see, but as I reviewed the design with Dr. Gears, she pointed out that the connections were not easily distinguishable. For example, while you can see the difference between the weakest and strongest connections, some of the others are too close to tell. At this point, I had been working in the development server. When we exported the visualization to the live server, it became ever more clear that the edges were not easily distinguishable. Here, we have Visualization D using the live server data. There were clearly two major improvements to be made. The first goes back to what I was saying earlier. Social networks that capitalize on weak ties and asymmetrical connections will be able to trace more accurate and useful paths. While this visualization had asymmetrical connections, I had thrown away some of the data. The second improvement to be made was an ability to filter out users or connections so that A, users could drill down into the network and find specific connections and paths, and B, curious users would have more to do. At this point, we can sate curiosity only by allowing users to play a sort of Where's Waldo to find themselves. But besides searching for users or dragging nodes around for fun, there isn't much for users to interact with. As for the data, let's go back to the connection questions. When a user answers this question, we derive a number to represent the strength of the connection. If a pair of users had each answered these questions about each other, and they had differing answers, for example, one said they had been introduced while the other said they had never interacted, I was averaging the results. This way, I was representing the best approximation of the relationship. But there was no good reason to approximate the relationship when I could show the actual connection. Here we have two stages of Visualization E. In the first, you can see that I've begun to distinguish between 1 and 2A connections, as I'd done with my first mockup. On the right, I've removed varying edge weights because they're messy and don't provide much benefit. If a user is curious about the strength of a connection, they have two options. They can hover over the connection to view the value of the connection or connections, or they can filter out connections by minimum connection strength. Here we have the visualization F5. I didn't skip F1 through 4, it's just that there were a lot of features added and code changed to get this point, and not a lot of visual changes. In F, I've broken the 2A connections down into two separate connections, each with their own connection strength. Now each connection strength is a true representation of the data available. But I also mentioned the need to filter connections in order to drill down into the visualization when there are lots of users. Here we can see F5 with the various filter options. These are meant to provide value to the users, allowing them to find specific connections that interest them. I've added maximum connection weight as a filter option, so users can seek out those weak ties, which are often bridges out of silos. Users can also choose to hide names and edges to tidy up the visualization when there are lots of scholars being displayed. One can also switch to what I call personal or central view. With central view, the user selects a scholar to focus the visualization on. They can then filter out scholars who are not within X distance of the central scholar. When the central view is being used, the visualization also reports on what percent of the network that user is connected to with the current filter settings. Everyone says to always skip live demos, but I think I'll risk it for a minute or two to show that the visualization does in fact work. So if we pull up the visualization, here we have it on the development server. So you can hover over a connection to see it. So for example, here we have Volo to Hull is a connection strength of 2. So if we filter out with the minimum connection value of 3, we hit apply options, then we can see that he disappears. So we have Volo here, and Hull is no longer here. If we show the nodes no relevant connections, then he's back, but he has no connections. If we click on Hull, it will change him to the central user. So let's click on central view, and let's make the distance 2. And if we apply the options, we can see that no connections are found. But if we reset this to 1, and we apply the options, we can now see that Hull Clyde is connected to 31% of the George network at distance 2. So some of these connections, as we saw, are connection strength of 2, 4, 4, 3, 3, and 2. So that's in dev. If we switch to live, we can see there's a whole lot more scholars. So it's definitely important to filter down. So let's do the same thing we did before. So let's go to the central view, which is defaulted to Deb Gears. And if we click on Clyde Hull, then updates to him. Let's make the distance 2. And we apply options. Now we can see there are even more scholars that he's connected to. But he's only connected to 25% of the George network at distance 2 because of how many more scholars were added to the whole network. So now let's return back to the presentation. I already mentioned that the applications of curiosity to the design of this visualization. Idealism can be considered part of the overall picture when you consider the connection questions. As users look over the visualization, they will likely want to make their place in the visualization more accurate. To do so, they would have to answer the connection questions and acquire a card which would automatically update the visualization, thus pushing it toward the ideal. I decided to avoid designing specifically for honor as I felt it would complicate the design too much. The only piece slightly related to honor is the border of each scholar node being colored based on college. Scholars can take pride in the efforts of themselves and their colleagues to connect to others across campus when they view the visualization. In the future, one could add metrics to allow users to compare the colleges and take even greater pride in their accomplishments. Let's go over some of the options for future work related to this project. The connection rating between scholars ranges from 1 to 7. As the database infrastructure is improved, the ability to query it will be improved as well. New queries could allow for the expansion of connection ratings in this visualization. If we decide to make assumptions about connections, we can strengthen them using attributes such as same affiliation or department. Students can currently report on their connections with scholars to obtain the digital cards of those scholars. In the future, students may want to see how they fit into the picture. For example, a student who has made some connections could use the central view feature at distance 2 to see how many scholars they could be introduced to through their first connections. I haven't stress tested this visualization much at all, but if the visualization starts to take too long to load, it wouldn't be hard to add a loading bar using the viz.js library. Also, we currently grab the data dynamically. We may decide to cache the data once a day, week, or month if the stress on the database becomes too great. While I rigorously tested and debugged my code on the development server, I haven't gotten a chance to test the visualization in live much, but I did already find that the edges aren't showing their connection weights when you hover over them. So troubleshooting that will be a first step for the next person to take on the project, or I might just do it for fun later. My advice to future graduate students is as follows. It can be tough with classes and projects going on, but try to take the time to complete your capstone proposals as soon as possible. I ended up doing mine during the break. Luckily, Deb and John were still willing to work with me. Next, try to avoid a project that relies on other work to be done first. I did very little work besides the mock-ups until the connection questions had been finalized and put on the website. Even after that, I needed to rely on Ravi for the queries. Luckily for me, Ravi and Ron were both very helpful when it came to working with Molly. So thank you, Ravi and Ron. Every time you talk to your advisors, you will get useful advice. Thank you, John and Deb, for the quick responses to all of my questions. My project was closely intertwined with George, but I tried to make sure it really stood apart from it. If you are doing something as part of a bigger project, make sure it stands alone. There were some points where I would keep worrying about the big picture as it relates to George, but Deb helped remind me that my project can and should stand alone. If changes to George were made during my time working on the project, I shouldn't drop all my work. I should continue what I was doing and document why. Lastly, I want to say thank you to Deb, John, Ron, Ravi, and the rest of the George team. And with that, I'm ready for any questions.